Hi everyone, welcome to 5.4 and here is example A. I want to invest $500 in a savings account so that its doubling time will be 8 years. So in 8 years I need $1,000, so I want to make sure that in those 8 years I'll have this $1,000. So what annual percentage rate is necessary for this to happen? Assume the interest on the account is compounded annually. Okay, so let's see if we can write our equations. We're going to say $1,000 equals our initial investment of 500, not 5,000, there we go. And we're going to say if its annual interest rate is going to be 1 plus R, because the 1 plus R says that it's going to be 100% plus whatever the rate is. And then we're going to say to some percent, let's just call that X. Okay. And so let's see if we can fill out some things. Well, first of all, we know X to be 8 years, right? So this X is going to be 8. And then what I'm going to do is divide both sides by 500, divide by 500. And I should end up with 2 equals 1 plus R to the 8th power. 8th power because we're having it for 8 years. Right? So if now we can just solve for R, that would be really, really good. So what we need to do is we need to take the 8th root of this, or we can take this both sides to the 1/8 power. It'll give you the exact same thing. So we can just say 1/8 power, and then we say 2 to the 1/8 is going to equal 1 plus R. So I need to subtract 1 and subtract 1. So I can say my answer should be 2 to the 1/8 minus 1 is going to give me the rate. So now let's just go through and solve it. So I can say 2 to the 1 divided by 8 gives me that number, and then I need to subtract off that 100% to give me 0.0905. So we can say then that our rate should be more than 9.05%. If it's anything more than 9.05, then I will have double the amount that I want. If it's anything less than this, I will not have enough. So about 9.05% is what I should be looking for as far as the percent. Okay, so there is example A. So now let's go to example B. Example B says a motion sensor is used to measure the distance between it and a swinging pendulum. A table is made to record the greatest distance for every 10th swing. At rest, the pendulum hangs 1.25 meters from the motion sensor. Find the equation that models the data on this page. Well, it's really right here. Okay, so what we need to do is we need to find an equation. So we need to think, what equation is this? Well, is it a quadratic? Is it a cubic? What does it look like? So just remember that as this thing is swinging, the pendulum is going to be slowing down as exemplified in this very short video. Alright, so here's a pendulum. It's just a, I don't know, computer image. Notice how the pendulum is slowing down. So eventually it will stop moving. So that means we know that eventually, if we were to graph this thing, we know that this line right here, wherever it stops, is going to be where the motion sensor picks up all the time. So we kind of need to find that number, which makes me think that this equation and the graph is going to be like a shifted geometric sequence because it's not going to go towards 0. It's going to go towards this 1.25 meters. So let's see if we can actually check out what this thing looks like. And so what we can do is we can graph it. So if I close this up, first you can see that I have the table of data just like you have on your sheet. And here is our graph. So we can see it starts here and it starts to go down. And we can say it's getting closer and closer to the line. Let's just call it, maybe I can just put it down here, y equals 1.25. Okay, so if we look back at our line here, we can say, you probably can tell that this thing is getting closer and closer to this line, and it's never going to go below because the farthest away, the closest that pendulum can get to the motion sensor after it stopped moving is this 1.25. Alright, so this is a shifted geometric sequence. So we're just going to write that shifted geometric, meaning we have to do some sort of exponential function plus or minus a number. Alright, so we can say we have y equals some a b to the x, right? And we probably have to add something to it. Okay, so what we're going to do is we're going to write the following equation. Probably right. Well, just to get a little more specific about maybe doing a point rate problem, point ratio form, we could say y equals y1 b to the x minus x1. All right. Now here's the thing. We know it's going to be translated up 1.25 meters, right? That means we can translate this up 1.25 meters. So we can say y minus, we're going to say y minus 1.25. Now you say, why minus? I thought it was plus. Because if I'm trying to get the minus 1.25 on the left side, I'd have to subtract it from this side. So if I want to subtract 1.25 here, it goes on this side. So we can say y minus 1.25 equals, if I wanted to move it up 1.25 from the y, any y value, I have to do it specifically to the y1 value, 1.25, and we're going to say b to the x minus x1. All right, so this is going to be our new equation that we can use. All right, so we're going to do this to some points that we have here. All right, so let's start to pick some of our values. Does it matter which ones we pick? No, but we want to try and see if we can get the b value to be either the same for all of them or some representative number of all of them. All right, so what I'm going to do first is I'm going to use this point right here. All right, we're going to use the point 10, 1.97. All right, so we're going to plug them in, and I think I am going to do it right over here. So we can say y minus 1.25 equals my y value, which is 1.97 minus 1.25. And we're going to say times b to the x minus x1, and x1 is 10. All right, so then we can maybe solve this. We can say y minus 1.25 equals 1.97 minus 1.25. That's going to be almost 0.75, so it's going to be more like 0.72 times b to the x minus 10. All right, so now I want to divide by 0.72, divide this by 0.72. All right, and that should kind of get us an idea of what b looks like. We can say b to the x minus 10 equals, we could probably just leave it right as y minus 1.25 over 0.72. So there we've kind of simplified for b here. Okay, so far that's what we've done. We just simplified this thing for this equation. Now we still have an x and a y and a b, so we just rewrote everything. Now if we wanted to solve for b, we would have to do this whole thing to the 1 over x minus 10 power, right? So we can rewrite that. I'm just going to write it over here as y minus 1.25 over 0.72. We're going to say all that goes to the 1 over x minus 10 power, and that's going to equal b. Okay, so there is one way we can get b. Now notice how in here we have a bunch of sets of data, and we can say x and y. We can plug in 0 for x right here, and 2.35 for y, and we can solve for b. We can do the same thing for 10, 1.97, 20, and 34. We can do it for all of these points. Okay, so what I'm going to do is I'm going to move all this stuff down just a little bit, and we're actually going to calculate all those values. And to save us some time, I'm not going to actually calculate all of them by hand. I'm just going to show you which ones, what are the b values for all of these. So let me just write them up here, and you'll see them in just a second. Ready? Aha, there they are. Okay, so we didn't do this one because this is the point that we chose. So we're not going to include that one in our values because it's not going to quite help us out very much. So if you notice, all of these are really, really close. 9541 is the one that happens the most, and so I'm going to choose that one. I'm going to choose the mode as 9541 because all these seem really, really close to it. This is the one that's a little bit of an outlier. It's a little bit farther away. So I'm not going to choose, I'm choosing not to use that one because I have all these other values that seem pretty close. So that means my new equation is going to be y equals, we can do y1, let's just write out our whole equation. Are you ready? We're going to use this one, so it's going to be, we can just do 1.97 minus 1.25 and just write it as 0.72, so we can say 0.72, and our b value is about 0.9541 to the x minus 10, and then don't forget that we have to add 1.25. I am running out of room, so let's just try this again. Let's just get all these guys. Oh boy, okay, we're just going to get these, and we're just going to write it down here, and we'll try again and move it over here. There we go. So we can say y equals 0.72, 0.09541, x to the x minus 10 to the x minus 10 plus 1.25. All right, and there would be our equation. Kind of a long, complicated process, but if we can't just find that b value very quickly, this is a way that we can try and find it. It's a little complicated in here, sure, but you can do it. All right, there you go.